Hello, Algebra 2. You've tuned in to the Unit 8 Lesson 1 video. Thanks for tuning in. Let's jump right into it. We're looking at trigonometry. Hopefully you have some memories of trigonometry in your geometry class. We're doing it in algebra as well. They are intertwined, most definitely intertwined. Let's start out with some definitions. Complementary angles. What does it mean for two angles to be complementary? Two angles are complementary if they add to 90 degrees. So two angles are complementary if they add to 90 degrees. So 20 and 70 are complements because 20 plus 70 is 90. And two angles are supplementary if they add to 180 degrees. So 50 and 130 are supplements to one another because 50 plus 130 is 180. The triangle sum theorem. What do we know about the angles of a triangle? The angles of a triangle add to 180 degrees as well. And the Pythagorean theorem says a squared plus b squared equals c squared. A and b are legs, and c is the hypotenuse. Okay? So those are some facts that hopefully are reminders to you and not really something new. Those are all four are covered in geometry. SOHCAHTOA, as I like to say, SOHCAHTOA. Sine, these are called the trigonometric ratios, a ratio because they are fractions, okay? So sine of theta is how we say this symbol, but theta represents an angle, okay? This is an angle. So sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse, and tangent of an angle is opposite over adjacent. So as a reminder, what do we mean by these words opposite, adjacent, and hypotenuse? Well, the hypotenuse is always the long side, right? This is h, the hypotenuse, the longest side of the triangle. It is opposite of the right angle. I like to say in geometry class that the right angle box is like an arrow pointing towards the hypotenuse. And then if you were to point out of the angle, it points towards the opposite side, and the side right next to the angle, so to speak, is the adjacent side. So that's our opposite, adjacent, and hypotenuse. Okay. So that's just our basis, our foundation. Let's dive into some problems. Find the angle that is complementary to 43. Well, 90 minus 43 is 47 degrees. Boom. Lovely. Find the angle that is supplementary. 180 minus 105 is 75 degrees. Boom. Those are pretty simple. Those are pretty straightforward. What about when we spice it up with a little bit of algebra? Find the value of x that makes the two angles complementary. So this expression, these two expressions represent an angle. So angle 1 plus angle 2 need to equal 90 if they're going to be complementary, right? That's what complementary means. So that is our equation. Angle plus angle equals 90. You go ahead and solve. 2 plus 3 is 5x. 5 minus 15 is negative 10. Add the 10 over and we get 100. Divide the 5 and we get 20. So x is 20. And you can kind of double check here that you did this correctly. 3 times 20 plus 5 is 65. That's the first angle. And 2 times 20 minus 15, that's 40 minus 15 is 25. And guess what? 65 plus 25 equals 90. They're complementary. So we did it right. Okay? We did it correctly. Find the value of x that makes the angle supplementary. We're using the exact same strategy here. The two angles add together, of course, because that's what you do for complementary and supplementary. They add to, this time around, 180 for supplementary. 25x plus 2 minus 22 is negative 20 equals 180. And then 25x, you add the 20 and you get 200. And 200 divided by 25 is 8. I'm not going to bother plugging it in this time, but just know that if you plug in 8 to each of these, you're going to get two angles that add up to be 180 degrees. Okay, so let's do what's probably the more difficult part of this lesson, the trigonometry. Okay? SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Please just chant that in your head at all times. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we want to find each of them. This is theta, right? So if the arrow points out, this is the opposite side. This box points towards the hypotenuse, leaving us with 8 as the adjacent side. What is the opposite side, right? We don't know at this particular point in time, but how can we find the opposite side? We can use the Pythagorean Theorem. This is a right triangle, and we know that leg squared plus leg squared equals hypotenuse squared. So 64 equals 289. O squared, sorry, plus 64 equals 289. Subtract the 64, and you end up with 225. And you take the square root. The square root of 225 is 15. So, okay, that side is 15. Now I can find my three values pretty easily. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Those are my three values: sine, cosine, and tangent. We use the exact same strategy on the next one. The angle is here, so this side is opposite, this side is adjacent, and this side is the hypotenuse. I highly advise that you label your H, O, and A, hypotenuse, opposite, and adjacent, okay? So that way you know which is which. We are trying to solve for the adjacent side now. It's still a right triangle. We can still use Pythagorean Theorem. So 8 squared plus a squared equals 24 squared. Remember, when you use the Pythagorean Theorem, don't confuse a here with like a squared plus b squared, right? It's the adjacent side, okay? But the value over here is always the hypotenuse. Leg squared plus leg squared equals hypotenuse squared. Has my webcam been like this washed out the whole time? Let me fix that in the matter of 2 seconds. 3, 2, 1. Beautiful. Okay, so let's go ahead and do the math though. 64 plus a squared equals 24 squared is 512 minus 64, that's a 6, minus 64. A squared equals 512 minus 64 is I gotta break out the calculator on this one. $512 minus 64 is 448. And when you take the square root of 448, can you take the square root of 448? It comes out to be a decimal. It comes out to be a decimal. Wait, sorry, what is 24 squared? Sorry, 24 squared is 576. My bad. And 576 minus 64 is 512. And then when you take the square root of 512, I think you still get a decimal. Yeah, you still get a decimal. We'll just leave it as a decimal. 22.6, okay? 22.6. So sine is opposite 8 over hypotenuse, 24. Guess what? That reduces to 1/3. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So when you use your calculator, to find sine of something, which is what the next questions are asking, right? Sine of blah, cosine of blah. What it's finding is opposite over adjacent and adjacent over hypotenuse and all that, right? That's what it's finding for you when you plug it into the calculator. So we've written our answers as fractions, but the answer can also be a decimal, okay? And let's round to the hundredths place, okay? 2 numbers past the decimal. So we can just plug into our calculator sine of 47. Now, I need you to realize, though, that there are different units here on our Google calculator. We want to make sure we're in degree mode. You see how that faded out? The degrees is faded. Now it's bolded a little bit. We want to make sure we're in degree mode, and sine of 47 is 0.73. If you were in radian mode and you did sine of 47, you're going to get a different answer. That's like comparing meters to feet, radians and degrees. The meters and feet, they just aren't the same. Well, either are radians and degrees. So make sure you're in degree mode. Sine of 47 degrees is 0.73. I'm just writing that down for 4A. Make sure you're still in degree mode. We're just practicing with our calculator, right? Do you know how to use your calculator? Negative 0.74. Again, just writing it down, not really doing anything. Tangent of 248. Making sure we're in degree mode, and we get 2.4. Round that up to an 8. Okay. So what's happening? Sorry, my thing is freaking out. There we go. So there's our few answers. Okay, this says we know what the value of sine is, but we don't know what the angle is, right? How does a trig function work, right? I don't need you to like be a super genius about trig functions, but what you do, a trig function is something that you apply to a number, right? You can take the square root of a number, you can take the log of a number, you can multiply a number by 2, right? It's something super simple, right? You can sine a number, okay? Well, you're taking the sine of an angle and out spits 2 over 11. Well, what angle helped you get 2 over 11, right? We need to go in reverse. So sine of 47 degrees is 0.73. But what if I just gave you 0.73? How do you reverse it back to 47? How do you reverse 2 over 11 back to the angle? You use the inverse function, okay? You use the inverse function to reverse it. So, whoops, wrong scene. You use the inverse function to reverse it. So, making sure we're in degree mode, you take the inverse. So what you want to do is you want to INV, inverse, of, and you see how it brings up these inverse functions? You see how everything changed? Inverse sine of 2 over 11. And what does that give you? Let's just round it to the tenths place this time. Is that okay? To the tenths place, I'm writing down 10.5 degrees. So when you reverse it, you get 2 over 11. The inverse trig function sends you in the inverse direction. Let's continue on. Inverse cosine of 0.597, right? If you're trying to find an angle, this is actually a big deal. You should write this down. If you're trying to find an angle, you'll be using the inverse trig function. Inverse trig functions help you solve for an angle, right? I am missing an angle measure, 53.3. I am missing an angle measure, right? That is the unknown. You're going to use an inverse trig function in order to solve for that angle, okay? Last one is the tangent. Inverse tangent of 1.2 gives me 50.2 degrees. Making sure we're in degree mode, right? So last page. So we're at 16 minutes. Let's do the 30-second recap, right? Sine is opposite, sine, cosine, tangent, SOHCAHTOA. You can observe it on a triangle. When the numbers get weirder, you can't exactly observe that on a triangle, okay? So you plug it into a calculator. Sometimes, though, you don't know what the angle is, right? Here we knew the angle. Here we don't know the angle. You use a regular trig function for these guys, and you use the inverse trig function for these guys, okay? Now let's do some more solving here, and this is what we're going to end on. Find the unknown pieces. Find the unknown pieces. Well, how long is AB? You need to use the Pythagorean Theorem. You know two sides and you're missing the third. Leg squared plus leg squared equals hypotenuse squared. 16 plus 49 equals hypotenuse squared. 16 plus 49. 16 plus 49 is 59. 65 is the two added together, and you take the square root, and you get, I'll use my Google calculator here, square root of 65 is 8.06. We'll call it 8.1. Approximately 8.1. Now, how do we solve for angles? Did you hear me 20 seconds ago? This is pretty important. Write this down. Inverse trig functions solve for angles. Inverse trig functions solve for angles. So, which inverse trig function do we use? That is the question. If I'm trying to solve for angle A, I've been given the opposite and I've been given the adjacent side. What function is that? Tangent. Tangent of theta is 4 over 7. Opposite over adjacent. What is theta though? What is the angle? Inverse it. If you inverse tangent 4 over 7, you get approximately, let's just call that 30 degrees. Theta is 30 degrees. True story. That is angle A. That is angle A. And if that is 30, you should kind of instantly know that angle B is 60. Why? Because you know that the three angles have to add up to 180. 90 plus the 30 we just solved for plus 60 adds to 180. And you've solved for all three missing pieces. Let's do it again and we're done. I just realized I haven't been asking any questions. I got so sucked into the notes. All right. One question here at the very end. Gosh dang it. I got so sucked into the notes, I totally forgot to ask a question. That's frustrating. All right. So, we know the hypotenuse, but we're missing both legs. We're missing both legs. Okay? What can I solve for pretty easily, though? I'm pretty sure I can solve for angle D pretty easily. Here's some multiple choice options on the screen. What is angle D? All right, so you took 2 seconds to figure that out. Angle D is going to be, what is that, 63 degrees? Yeah, 63 degrees. Had to do a little bit of mental math there. 63 degrees. 63 plus 27 is 90. 90 plus the 90-degree right angle is 180. Boom. So 63 degrees. How do we solve for DF and EF? This is different. This is different. Let's set up an equation. We know that this is 27 degrees, and we're trying to find the opposite side, right? We know the hypotenuse, but we're trying to find the opposite side. What relationship is that? Sine. Sine of 27 degrees is opposite, but we don't know that side, over hypotenuse, 13. Right? You see how that setup makes sense, right? Sine of 27 is going to be opposite over hypotenuse. But the thing is we don't know the opposite side. We're trying to solve for that opposite side. So if we're trying to solve for that opposite side, solve for O. Multiply by 13 to cancel that out. So 13 times sine of 27 degrees equals O. And that is something you can just plug into a calculator. So let me go ahead and pull that calculator up. 13 times sine of 27 in degree mode is 5.9. DF is 5.9. I want to help you set up the next one, and then we'll have one last question here. So 2 questions on the last example. So we know that D is 63. You know what? We don't even need D. Screw D. We're just trying to find the adjacent side now, right? Instead of the opposite side. So what function is that? We know we don't know A, but we know H. A and H, SOHCAHTOA, that is cosine. So here's me helping you with the setup. Cosine of 27 degrees is adjacent over hypotenuse. Look familiar? It's just that instead of using sine, I've now used cosine. So here's some multiple choice options on the screen. What is the value of A, aka our adjacent side? All right, hopefully you plug that into your calculator. You said, okay, I'm just going to literally copy paste what he did in the previous problem. Yes, exactly. Please do that, right? You're trying to solve for A instead of O. We used cosine instead of sine. We're in degree mode. 13 times cosine of 27 degrees is 11 we'll call it 6. 11.6. And with that, ladies and gentlemen, we've done a deep dive into trigonometry. I hope that some of it came flooding back, and I hope anything that didn't come flooding back, you picked back up on it fairly quickly, because I'm not going to lie, this is word for word, pound for pound, exactly what we do in geometry. So hopefully things are coming back for you just a little bit. All right, thank you for watching. A little bit on the longer side, but I appreciate you sticking it out. I'll catch you in class. Thank you very much.